Okay, so hello everyone. I'm Rafael from the Java Challenges Initiative, and today we're gonna see a concept that is not uh, a lot used, but is also very important because it's a core feature from the Java language. And this feature is called shift operator. So let's see the code then. I'm gonna share my screen with you. Okay, so that's the challenger, and I don't know if you ever seen this operator in Java. So this operator is called signed left shift operator. And the second one is signed right shift operator. And the last one is called as unsigned right shift operator. And here basically we are printing the decimal number and the binary number, and here we are printing the information of the signed left shift operator, signed right shift operator, and finally the unsigned right shift operator. So I'm gonna give you some time to think about this challenger and let me know when you're ready to come up with the output of this challenger. Okay, I'm gonna just run this program and let's see what's gonna be the answer. And yeah, so at least the decimal number and the binary number got right, the rival. And it's fair that you don't know yet this concept, but you're gonna learn that now. So I'm gonna explain to you what's happening here. Okay, as you can see here on the output, we have the decimal number 20 and the same decimal number 20 represented by a binary number as 10 and 100. In the first line here, we're going to use the left shift operator. So what the left shift operator does, it will basically shift the binary numbers to the left. So what's going to happen? As you can see here, the 101 was here on the third position, okay? But if we use the left shift operator, we're gonna be moving this binary number 2 positions to the left. So as you can see here, it is on the third position. And here it is on the first, second, third, fourth. It is on the 5th position. As you can see, 101 jumped 2 positions to the left. And when that happens, the decimal number goes up. So on this case here, the number 20 multiplied by 4 will be 80. And if we use 1, it would be the double, okay? And the right shift operator is gonna do the opposite. So as you can see here, the 101 is on the third position, but as we used the right shift operator, it's gonna go 1 position to the right. So as you can see, the 101 was here, and then when we use the signed right shift, it goes 1 position to the right, which makes the decimal number be the half. Okay, so we had 20 and we've got 10. And the unsigned right shift operator will do the same as the signed right shift operator if it is a positive number. For example, here we had the 101 on the third position again, and on the unsigned right shift operation, it goes 2 positions to the right. That means that it's gonna go here. So Java will not show the number zeros on the left here, but it doesn't matter. With a binary number, 0 on the left is like nothing, so it doesn't matter actually. But if the binary number goes 2 positions to the right, then the decimal number will become 5, on which if we multiply 5 by 4, we would have 20. So I wrote an explanation here just to make it more clear. The left shift operator, so this is the binary number, and as you can see, 101 is here, and then if it goes to the left, it's gonna be here. Yeah, so if we use here 2 times left shift, so we're gonna have exactly the number that we had on the first operation. And then the same situation will occur here. We're gonna be moving the number 1 time to the right, and here we're gonna be moving our binary number 2 times to the right, which makes those numbers either become the half if we are using just one shift, or become the double. I can show you if we change the left operator, we're gonna have the double. We're gonna have 40 for the left shift operator. Yeah, as you can see, with the left shift operator, the 101 was moved once to the left, and this binary number represents 40 to the decimal number, which means that if we use the left shift operator to the left, we're gonna be doubling the number, so the number will become the double. And if we use the right shift operator and just by 1, we would be getting the half of the number. That's pretty much it for this challenger. Do you have any questions, Verival?
Yes, if you put you can put any number on this operator. You can put 2 or 3 or 4. There
Yeah,
is a limitation or
there's
not?
no limitation. So for example, we have here 1, 2, 3, 4, 5. So if we try to go to the right more times than the numbers we have here, we'll have 0, because I mean there won't be any numbers left. I can show you. So if we put 3, let's print and see what's gonna happen. You see, we have 10. If we put 4, we'll have 1. If we put 5, there won't be any space to shift, so it will be 0, the final result. So yeah, if we go 1 position to the right, it's fine. If we go 2, it's fine as well. The problem is if we go more times than the actual binary number, then there won't be any position. And
All right, very interesting. I have a second question about when you increase one number to the left, we always have the double of the number. I see that there is a proportion of how it multiply or how they divide as you go to the right or to the left. This proportion is dividing or multiplying the number.
exactly. So, for example, it will always be the double. So, for example, if we put just 1, it's 40. If we put 2, it's gonna be 80. And if we put 3, it's gonna be 160. And if we put 4, it's gonna be 320, and so forth. So it will be always getting the double of the value, the double of the last value. And for the right shift operator, it's gonna be the opposite. So if we put 1, it's gonna be the half of 20. If we put 2, it will be the half of 10. And if we put 3, it's gonna be an integer number, so it won't be exactly, yeah, it won't be exactly the half of 5, because we are returning an integer number, but yeah, we have 2 anyway.
All right, it will be rounded the next integer.
Exactly. But the idea is that the left shift operator will double the decimal number and will shift the binary number to the left. So yeah, the left shift operator will have the double of the value, and the right shift operator will bring the half of the number, and it will shift the binary numbers to the right as well.
And about the unsigned, it has the same proportion. Does
So
it
the
have?
unsigned right shift operator will work at the same way here, because we are using a positive number. But if we use a negative number, it's completely different. I won't go deep into this subject now, because otherwise this challenger will become very extensive. but I will explore this concept in another challenger. But for now, just keep in mind that if the number is positive, it will have the same behavior from the normal right shift operator.
Okay, that's good.
Good stuff. Do you have any further questions?
No, it's fine for me. Learned a lot. Thank you
That's
very
great.
much,
I'm
man.
happy to know, man. This is not an easy
Very good.
subject to explain, and if you understood that, I'm really happy for that.
Yes, I always was curious, but I didn't stop to go deep and know the details about those operations. Sometimes I saw the operation in algorithms, but I didn't have to change nothing. So sometimes I saw there is an operation, but I didn't go deep. But today it was a good opportunity to know better and know how exactly it is changing the number. Very good explanation, man. Thank you very much.
Thank you, Dorival. That's really nice to hear. Okay, guys, so that was the challenger of today, and you just saw one of the concepts that very few Java developers know. So, yeah, if you know this feature, it's good because you can build your algorithms with more performance. And, very often we have to solve complex algorithms and we have to think about performance and we have to elevate performance to the highest level. So it's very handy to know what is the right shift operator, the left shift operator, and definitely it's a core concept that is very important for every Java developer. So if you want to know more, you can go to javachallengers.com and then you're going to have access to plenty of concepts. And don't forget to get the code. So the link to the code is on the description. You can just um, download the code, run your own tests, and then you can um, really absorb the concepts of the challengers because the most effective way to learn is through watching videos or and running your tests and reading. If you do all those three actions, for sure you're gonna learn the concept. Okay, so if you like the video, please give a like and get subscribed because on that way you're going to help me out to produce better videos to you. And also we're going to be tuned in all the new videos that are coming up in the Java Challengers initiative. And that's pretty much it. Thanks everyone for watching and see you the next time.